This is measurement video number 2, and the topic is significant figures. Today we're going to talk about significant figures because when we do a lab or we do any measurement in the lab, there's always some type of error and uncertainty, and we want to know how many digits would be considered significant or we should include in our data. So when you read a thermometer, the thermometer reading has a graduation for every 1 degree Celsius. So the most accurate temperature you can report without giving more information than is actually true is to the nearest tenth of a degree Celsius. That digit, the tenth of a degree Celsius, is significant. For example, look at this ruler. If this is a centimeter ruler, we know for sure that it's 4, but we could estimate one place past, so we could say 4.5 centimeters. We can always estimate between the smallest marks. If we're looking at this ruler, we can measure and we could estimate, let's say, we know for sure it's at least 4.5, we could say 4.55. The more marks there are, meaning the better the instrument, the better estimate we could actually make. However, we still know that that last digit, so the second 5 in this case, 4.55, that last 5 is a significant digit. So here we go. These are the rules for significant digits. You may want to replay this slide over a few times to help you remember the rules. The first one is not so bad. Every number that's non-zero, meaning 1, 2, 3, 4, 5, 6, 7, 8, or 9, when it appears in a measurement will always be significant. So for example, the number 354. None of those numbers are zeros, so that contains 3 significant digits. The number 42 has 2 numbers that are non-zero, so 2 significant digits. The rest of the rules are really going to deal with zeros, so let's take a minute to go through each one of them. If you have a 0 that's between non-zero digits, they're considered significant. That just means that if the zeros are squished between 2 numbers that are not 0, so for example the number 7,003, the 2 zeros are squished or sandwiched in between the 7 and the 3. So this would be 4 significant digits, the 7, the 0, and the 3. The number 40.79, the 0 here is squished in between 2 digits that are significant, the 4 and the 7. So this would also be 4 significant digits. And 1.503, again, the 0 is squished. So whenever you have a 0 squished between 2 numbers that are significant, it's going to count as significant. The next rule has to do with zeros that are placeholders. When you have zeros to the left of a number, so for example 0.0071, those are just placeholder zeros. So those zeros to the left, they don't count as significant. So in this example, just the 7 and the 1 are significant. So this only contains 2 significant digits. The number 0.42, the zeros are appearing to the left of the number, so they are not significant. 0.000099, again, the zeros are to the left of the number. They serve as placeholders. They are not significant. So all 3 of those numbers only have 2 significant digits. The next rule has to do with zeros at the right of the number. Zeros at the end of the number to the right of a decimal point are significant. So here, 43.00 to the right of a number, and they are after a decimal point, after a number that's significant. Here, these zeros are to the right of a decimal point, and they're after a number that's significant. Zeros to the right of the number, they're after a decimal point, after some other number that's already significant. So all those have 4 significant digits. This is different than the last rule that has 0 to the right of the number, but there's no decimal point. So 300 only has 1 significant digit. If it was 3.00, it would be 3 significant digits. Actually, if you also said 300 decimal place, it would be 3 significant digits. But the number 300 just has 1. 7,000, the zeros are to the right of the number. I could make there be significance if I were to do 7.000 would be 4 significant digits times, let's say, 10 to the third. Or if you put a decimal point at the end, I can make them significant. But as it stands right now, each one of these numbers, the zeros at the end are not significant. So zeros at the end or to the right of the number will count if there is a decimal point and then the numbers, or if you have the number like 9,000 and then a decimal point. But if there is no decimal place, the zeros at the end of the number do not count. So let's go through some practice examples to try to help you familiarize yourself with the rules for significant digits. Starting with letter A. Remember that any non-zero number is significant, so we know we at least have one significant digit with the 5. Zeros to the left of the number, so to the left of the 5, don't count, because zeros on the left-hand side of a number are just placeholders. Zeros to the right of the number, the 5, do count if they're following a decimal. So since there's a decimal here, the zeros on the right count. So this is the 5, the 0, and 0. This would be 3 significant digits. Let's look at letter B, 25,000. Well, anything that's not 0 counts, so we at least have 2 in the 5. Zeros to the right of the number only count if there's a decimal before it. So there's no decimal anywhere to the left of these zeros, so there's 3 zeros to the right don't count. Because remember, the rule for zeros on the right is they only count if they're following a decimal. Let's look at letter C, 4.50. All non-zero numbers count, so the 4 and the 5 count. The 0 over here is to the right, so zeros on the right only count when they're following a decimal. Here's a decimal, so they count. So this would be 3 significant digits. Letter D is 20.1. The 0 is squished in between 2 non-zero numbers, so it counts. So the 2, 0, and 1 are all significant. This is 3 significant digits. Letter E is 0.101. Zeros to the left of a number, so the first number we see is 1. Zeros to the left of the number are just placeholders, so that 0 is not going to count on the left. The second 0 is squished in between the 1 and 1, so that counts. So this is 1, 2, 3 significant digits. Letter F, 60.001. These zeros are all squished, so they all count. So this is 1, 2, 3, 4, 5 significant digits. Letter G is 3.5 times 10 to the negative second. The 3 and the 5 are both significant, so this is 2 sig figs. When we're looking at significant digits, you don't have to look at the power of 10 or the exponent. We're just looking at the number over here, the 3.5. And in letter H, 0.04080. Zeros to the left of the number, so here's the number, first number we see is 4. Zeros to the left are just placeholders. They don't count. Zeros to the right of the number count when they're following a decimal. So up we see a decimal, so all the zeros to the right will count. So this will be 4 significant digits. So I'd like you to take a minute to try numbers 1 through 10 in your notes. Again, you might need to take a second to revisit the video or look at the sheet in your notes, just memorizing those sig fig rules. And after you finish 1 through 10, there's a learning check in your notes if you could do those as well. This concludes the end of measurement video 2.